Okay, so I want to show you this idea of linear programming actually in action with a real-world example. So let's suppose that we were farmers that are producing two kinds of fruits. We're producing mangoes and kiwi. Two, by the way, of my favorite fruits in all the world. You got the mangoes, you got the little gentle kiwis going, two different kinds of fruit. And what you want to do is you want to sort of figure out how much of each of these should you produce. Now here's the deal. It turns out that for every acre of mango that you produce, that you grow on your farm, you get $70 profit from every acre. And from every acre of kiwi that you actually produce, you get $50 profit. Now, of course, you know, mangoes and kiwis just don't grow on trees. Or maybe they do, I don't even know. But it requires a little bit of work and cultivating and so forth. So you actually need, for each of these things, you need a plow, you know, and then you need a tiller to sort of, you know, do the thing. And let me tell you how this works. To sow an acre of mango land, what you need is 3 hours on the plow and 2 hours on the tiller, and that's per acre. Okay? Now, to sow an acre of kiwi, that actually requires 4 hours of work with a plow and only 1 hour of tilling, so only 1 hour of the tiller. Okay, now you're going to rent these things, by the way. You're going to rent the plow and the tiller because you don't have that kind of, you know, machinery around. And you can only rent the plow for, at most, 200 hours because then you can't afford it otherwise, or you have to give it back or whatever. And the tiller you can only have for 100 hours. So you can take the tiller for 100 hours, you can take the plow for as much as 200 hours. And the question is, how many acres of mangoes should you have? How many acres of kiwi should you have to maximize profit? That is really a mouthful of question there. How do you even untangle it? Okay, well, let's think about it. Let's figure out, we have to figure out what number of acres of mango we're going to have and what number of acres of kiwi we're going to have. So let's give those things, those unknowns, names. So let's let M equal the number of acres of mango. And let's let K denote the number of acres we're going to grow of kiwi. And our job is to figure out what M and K should be, given all the constraints that we have. By the way, there are constraints here. We can only have the plow for up to 200 hours. That's a constraint. We can only have the tiller for up to 100 hours. That's a constraint. So those are constraints. But what do I want to maximize with those constraints? Well, I want to maximize profit. At the end of the day, it's all about money. Mangoes actually turn into money. And so, in fact, what you want is a lot of money. So we want to maximize profit. So what's profit equal? Well, let's write that down. So profit would equal, well, remember, we know that we have $70 profit per acre for the mangoes we grow. And if there's M acres of mangoes, then the profit from the mangoes would be 70 times that. So we'd have 70M. And then we have to add to it the profit that the kiwis bring in. And I already told you that the kiwis bring in $50 per acre of kiwi. So we have 50 times the number of acres of kiwi, which we're calling K. So this is the object we want to maximize here. And you notice, by the way, that this is a linear thing. So in fact, we're doing some sort of linear programming. Now we have to figure out what the constraints are. So what are the constraints? Well, there's a constraint on the plow, and there's a constraint on the tiller. Let's think about the plow first. Now, what's the constraint on the plow? Well, first of all, how long would I need to use the plow? Well, remember, I need to use the plow 3 hours per acre for every acre of mango. So that means for the plow, I have 3 hours per acre of mango. So that's how many hours I'm going to need for the plow just to do the mango acreage. Then I have to add to it the many hours I need to do the kiwi acreage. And how much is that? Well, for the kiwi, I already told you that to sow the kiwi, I need 4 hours on the plow. So in fact, I need 4 hours per acre, so 4K. So that's how many hours I need just for the plow. Okay, now how much time do I have to have that plow? Well, remember, I only have the plow for up to 200 hours. So in fact, this has to be less than or equal to 200, and there's a constraint. Because the total plowing I can do has to be less than 200 in terms of time. Okay, now what's the other constraint? Well, I have the tiller too. Now how does the tiller work? Well, I need 2 hours per acre for the mangoes, and so that's going to be 2m plus the number of times I need, number of time times the number of acres for the kiwi. Well, I only need an hour of tilling for the kiwi because they're so small. Look how small they are. They're pathetically small, but beautifully delicious. Okay, so that's 1 hour for every acre, so that's just plus k. And how long do I have the tiller for? Only 100 hours. So these are the 2 constraints that I have. And under these constraints, I want to maximize profit. So what should I do? Well, the first step is, first of all, to graph these constraints in terms of their picture, and then look at the vertices, and the vertices should give me everything. So let's graph these constraints, shall we? So let's see. Let me graph the first constraint here. Let me see if I can actually do it right here live. I think I can. I think I can. I think I can. So here are my axes. Let me have this be the M axis, the mango axis, and let's have this be the kiwi axis. That's what I'm graphing here, M's and K's. So to graph the first thing, I see 3m plus 4k, and let's suppose it equals 200 at first. So let's just put in that line somewhere. So I'll find the intercepts. So if I let m equal 0, let the mango number be 0, that will tell me what height I am here. And if I do that, what do I see? Well, if I put in a 0 here, I just see that 4k equals 200. And so if I divide, I'd see that k would equal 50. So if I divide both sides by 4, I would see k equals 50. So the intercept here is going to be at 50. So this is at 50. And I'll write that in here, 50. I'm going to write this in stronger later, but that's 50 right there. Now, suppose that k were 0. If k were 0, I can solve this for m by dividing through by 3. I have 200 over 3, which would give me 66 and 2/3. So in fact, I'm way over here at 66 and 2/3. This is 66 and 2/3. And I draw that line. Now I know that that line's not going to go off to the negative regions because I can't have negative acreage of kiwi or mango. So in fact, it's only in the first quadrant. Okay, fine. Now let's take a look at this second graph. How would that look? Well, if I let k be 0 there, then I can solve for m, and I'd see that m would equal, well, it would equal 50. So m would be 50 here. So here I'd be at 50. This is 50. And if I let m be 0, then I see that k is 100. So in fact, that's pretty easy. I go way up here. Whoops, wrong pen. This would be 100. Way up here. So that's 100. And if I connect these, I get this region. All this work, by the way, is just to get the region. Now, where is that region? Well, I have to be under this line, since this thing is less than 200, and also under this line, it's under 100 here. And so what I see is I have a region that looks like this. It's this little light region right in here. And you can see what I actually have, therefore, are 4 vertices. And I know that the maximum of the profit will be at one of these points. So all I've got to do is find the points. Well, this one's easy, because that one I know is an intercept. So that one's at 0 mango, 50 kiwi. This is also easy, because that is 50 mango and 0 kiwi. But this point here, I've got to find the intersection of those 2 lines. So now I actually have to go off and do a separate problem. I've got to find out where these 2 lines intersect. Let me just outline that really fast. So I take these 2 lines, 3m plus 4k equals 200, and I want to take 2m plus k equals 100, and I want to solve them simultaneously. So what I'll do is I'll actually take the bottom equation and multiply it through by, let's multiply that through by 4. So then I would have 8m plus 4k would equal 400. Then let me copy down this equation just as is, 3m plus 4k equals 200. I'm using the elimination method. And if I subtract, I see 8 minus 3 would be 5m. This drops out, and here I just see 200. And so what would this be? Well, m would have to be 40. So in fact, that intercept right here is where m equals 40. And so what's k there? Well, I just go back and plug in 40 in for here, for example. So 40 times 2 would be 80, and I would bring the 80 over, and I'd see that k would have to be 20. So I now have all the points. I also have this point right here, which is 0, 0. But you can see 0, 0 would generate no profit. So in fact, that I hope is not going to be the maximum. Otherwise, we're losing money. OK, so all I've got to do now are take these points, 1, 2, 3, and plug in here and see which one gives me the biggest. So if I plug in 0 here and 50 here, so remember 0 is the m, so I put in 0 here and 50 here, then what do I see? I see a profit of, let me just draw this out here really fast. I'm going to draw this little region here. So the profit here would actually be 50 times 50, which is 2,500. It's a lot of money. What if I look at the profit here? Well, then I put in 40 for m and 20 for k, and I compute what that is. And if you do that, you get 3,800. And finally, if you do all mango all the time, that's 50 mangoes and 0 kiwi. If you compute that, you would see 3,500. And this produces a profit of 0. So where's the maximum? It's going to be right here, which means I should have 40 mangoes producing 40 acres of mangoes and 20 acres of kiwi, which sort of makes a little bit of sense because, of course, you know, mangoes are actually a lot bigger than kiwis, so you might want to have more of them, you need more space. And mangoes, by the way, are delicious. Do you know how to eat a mango? They're so good. Look at that. Look how fresh that looks. I just grew this one myself. You can take a nice spoon and you can taste it. They're very succulent. Oh, man. I'm in mango heaven. This is really good. You know, I'll tell you, the great thing about word problems is that after you're done, you get to sort of, you know, appreciate the fruits of your labor. Well, you are making kiwis. So you just cut off a kiwi. Look at that. Is that a beautiful kiwi or what? I feel like sort of Julia Child here, but you can just peel off a little bit of kiwi right in there. Look at that. Oh, does that look tempting? Math. So delicious. Oh, man. That is a killer kiwi, I gotta tell you. Anyway, you can see that even though these linear programmings require a little bit of work, you gotta sort of graph the stuff and make the things. The point is, it's really worthwhile because not only can you figure out profit, you know, angles and stuff, but you get to eat the props. Really cool. Anyway, bon appetit.